Hello and welcome to my video on how the spark plug operates within the Honda GX160 combustion engine. The spark plug is a device located in the combustion chamber of a spark ignition engine designed to periodically spark and ignite compressed fuel vapor without any loss in pressure. As shown in the picture to the left, the spark plug electrodes are located at the top of the combustion chamber and it's designed to spark at the exact time the piston is highest and the fuel is most compressed to get the highest combustion rate and in turn efficiency of the engine, as visualized by the graph below. Now, in order to understand how spark plugs actually work, one must understand first the concept of magnetic induction. Now, Faraday's law is a law that states that when a magnetic flux linking a circuit changes, an electromotive force is induced in the circuit proportional to the rate of change of flux linkage, as shown by the equation. EMF induced is equal to the number of coils times the rate of change of flux linkage, and is in the opposite direction to the change of magnetic field. Now, this essentially means that any coil of wire can produce a magnetic field, and does when in a region of changing magnetic field, as to oppose that change of magnetic field, producing an EMF in the coil, and if the coil is in a complete circuit, a current may flow. Now, this can be visualized in the following sort of chain of reactions, in which a bar magnet falls through a coil. And as it falls into the coil, there's an increased magnetic field, so the positive EMF is induced, and while it's in the center of the coil, the south magnetic field and north magnetic field cancel out, so no EMF is induced overall. And as the magnet leaves the coil, there's a decreased magnetic field, so EMF is induced in the opposite direction. And as it's falling, it's in free fall, it's accelerating as it goes down, so there's a greater rate of change of magnetic field and a greater EMF is induced. Now, Faraday's law can be applied to the Honda GX160 engine, as there is a magnetized flywheel which rotates next to an induction coil connected to in a circuit with the spark plug, producing an electromotive force in the circuit, which in turn creates a current which flows and creates the sparks in the spark plug terminal. Now, if you were to plot a graph of the voltage time as the flywheel rotates with consistent angular velocity, it causes a graph which looks like a sine graph, which means that the engine can be designed to have the fuel fully compressed when there is the greatest potential difference across the spark plug terminal. And the graph looks like this graph below. An extremely large electromotive force is needed to generate the necessary potential difference of 12 kV to 50 kV across the terminals of the spark plug to create a region of sufficiently high electric field strength, as shown by the equation. Electric field strength is equal to voltage of the separation between the two plates, sufficiently ionize the air so that the current can flow and the spark can be reduced. This is kind of shown by the visualization below, and explains why the start chain must be pulled before the engine starts to get the flywheel spinning fast enough to generate a voltage large enough to create a spark. Once the engine is already started, the engine is self-sustaining. Alright, so that's been my video on how the spark plug works in a spark ignition engine. I hope you enjoyed. Please like, subscribe, and yeah, take care.